Today on the Perception and Action podcast, Perception and Action Journal Club number 7. Looking at the article, an internal focus of attention is optimal when congruent with afferent proprioceptive task information. So it's time for a call to action. Hi everyone, this is Rob Gray from Arizona State University and PerceptionAction.com. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. In today's episode, I'm joined by Vicki, Gottwald, and Gav Lawrence from Bangor University to discuss their interesting new paper. As I discussed way back in episode 7, Toner and Moran have proposed that there could be some situations that go against the dominant research finding in motor learning that an external focus of attention is always best. In particular, they argued that there are certain tasks and situations in sports that require somesthetic awareness, or a focus on feel. In such situations, like when trying to modify a well-learned technique, they believed that an internal focus might be superior. In their study, Vicki and Gav test this idea by varying the importance of proprioceptive information for a series of different tasks, and find some really interesting results. Hope you enjoy. Yep, there we go. We're live. So welcome everyone to another edition of the Perception and Action Journal Club. Today I am joined by Gav and Vicki from Bangor University in lovely Wales. Gav has a nice background showing it off for you right now.
Yeah.
I'll let you guys introduce yourselves a little bit first. Maybe what you do in your role and your interests. So let's start with you, Vicki.
Okay. So my background was initially in secondary teaching, and then in later years more so in coaching with our basketball world national teams over the years. And I was back teaching in schools, and Gavin, you've probably forgotten this, but Gavin first shared Gabby Wolf's, it was a 2007 review paper with me, and I remember being fascinated by the impact that a simple instruction can have on performance and changing those instructions, and even more so the fact that actually by giving instructions, sometimes actually we can be doing more harm than good. So I remember being pretty excited by those findings and beautifully sharing them with my colleagues who were pretty dismissive at the time, if I remember. If anything, I think that encouraged me to want to take up a research career in that field. And so I went on to do my PhD with Gavin and Mike Kahn. And probably the first thing to say is that I don't really have any doubt that an external attention can be really valuable for athletes and a really valuable coaching tool. But I suppose for me, I'm probably just a bit skeptical of maybe the black and white nature of the field, and I'm quite interested in situations where actually maybe an external focus is less effective for whatever reason. So I'm sure we'll get on to talk about a lot of those today.
Yeah, no, that's great. I like how you set up your interest in this area. Gav, how about you?
I guess the interest in focus of attention has just come because of the massive power associated with the research findings. They're just consistently finding that this external is better until this paper, right? But really, background is in visual control and aiming, reaching and grasping and target-directed aiming movements, and looking at online and offline control of actions. And then moved into sports science, so from experimental psychology to sports science, on the basis that if we can understand the underlying movements and those processes, then we can apply them to sports-based skills and try and enhance expertise. So I've got sort of a mixed background really with that experimental psychology and motor control and learning, and then now into more skill acquisition-based line of research and talent development. And this, the paper we're going to discuss sort of marries those two together quite nicely, actually. It's quite exciting that finally, after 20 odd years, we've got something that merges together, and I haven't got these two separate bodies of research.
Yeah, I was surprised when I was reading it. Your third experiment was a different kind of twist on things. So what we want to do today is, as we've kind of been alluding to, is I'll put up the this talk about your new paper. This is the paper, Internal Focus of Attention is Optimal when Congruent with Afferent Proprioceptive Task Information. So I should say, anyone following along, feel free, you can post questions in YouTube or whatever, and I can pose them to Gav and Vicki later on. Well, I guess when we start, what was kind of, where did this idea come from? You know, what was sometimes they do have research ideas come out of nowhere, I know, but was there a reason you wanted to kind of tackle this this connection between proprioceptive information and focused attention?
Yeah, so I suppose initially, I suppose it'd be a bit remiss of me not to say this particular series of studies was probably quite largely influenced by some of the commentaries and position papers in PSE from John Toner and Aidan Moran before his passing. So I think that had a big impact on the research. And as I said previously, it's that interest in some of those situations where perhaps an external focus isn't as effective. And then, I mean, Gavin talked about aligning his two sort of research areas between skill-ac and the underlying motor control. So that was a bit of a starting point for us. We started playing around with some aiming tasks and found that actually just saw this benefit in pilot data with the internal focus of attention. And then it went from there, trying to think about why. And then we went down the line of receptive tasks and situations where you get this congruence, I suppose, between afferent information that's important for task success and focused attention. Gav, I don't know if you want to add anything.
Yeah, but agree with that totally. And then the other side was from a sports perspective. I remember always having good chats with Mike Kahn about, in fact, I wonder when you're really elite at something, having a self-focus is really beneficial for you. And his anecdote was also, he always talked about Tiger Woods. I don't know if this story is true or if it's just Mike selling stuff to me, but it was you could pick up a golf club that was made specifically by him for Nike and say, no, this is too heavy. Mm-hmm. Just by the feel, and then they would go and test it and go, oh yeah, it's like 3 grams heavier than it should be. So his body awareness and his proprioceptive feedback was just phenomenal because he's so good at that task. And I wondered, are we good at tasks where proprioception is just, that's what we use it for, that's what we do, and that sort of stemmed into, well, we reach and point at things all day, maybe this is a good task to start with.
Yeah. No, I was also, the couple of things that you're right. I remember that those couple back and forth pieces in the with Gabby and Toner Moran. I think the term they use is somaesthetic awareness, right? And they're kind of talking about how an internal focus might be beneficial, for example, when you're trying to modify your technique or something like that. Also, is brought to mind, I don't know if this relates at all to your PhD work, Vicki, on you're looking at kind of more form sports like gymnastics, right? It's kind of
when that when you don't have that sort of obvious, there isn't a bat or a ball, so you are a bit more reliant on that sort of proprioceptive information potentially.
Mm-hmm. Yeah. So I think it's a really interesting question, and so let's go into the actual study. So you use this task that you've been using. You've used a lot of times, right? Is Mike Kahn the
this was that's Mike in the picture now. This was these tasks are basically the sort of 4.5-5 years of my PhD life, just stuck in a lab with ping, move, ping, reaching. So I thought it's only fair on Vicki and the subsequent PhD students that they ought to do the same boring tasks that I did. So that's
you somehow made me even do it too.
yeah, that's true. I got you there. Oh yeah.
Actually, for me, Gavin, it was a nice change from a golf putt.
Yeah, that is true. Actually, yeah.
So can you give us a little description of the task, basics of the task?
You want to go, Vic, or me?
I'll start, and then you can add what I missed. So I suppose experiments 1 and 2 were an aiming task. So participants hold a stylus or a pen which runs along a track, and movements of that pen are reflected by movements of a cursor on the screen in visual conditions. So there's a start position, and then there's 3 targets which are placed vertically above, I can't remember, about 20 centimeters above the start position. One of those targets turns green, and participants have to move the cursor to the target as accurately as possible. So it's there, Gavin?
Yeah, it's a 2D graphic movement, so that what we can do is you can really then look at the movement in detail in terms of the kinematics, which until we had an Optitrax in the department, that was a difficult thing to do. We could only really do things 2-dimensionally. And for these tasks, when you're aiming to a static target and you're not trying to grasp it, if we fix them on that graphics tablet, i.e. they're in 2 dimension, then we don't really need to worry about that Z movement. It is a nice smooth sliding movement across, like when you're moving a cursor on a mouse, basically on a pad on your laptop. So you can get really nice accurate data on these, very minimal error data with the aiming accuracy of that. And it's been used, it's not our task, I guess, it's been used massively in the aiming literature. Digby Elliott, Luc Breteau, those guys are churning out this research since like late 90s up to current day.
Yeah. And,
I suppose.
Sorry.
In terms of being able to understand some of those sort of underlying motor control mechanisms, so how we plan movements or how movement adjustments might need to be made online, so our online, offline control. The task is a really nice way to measure those. Yeah,
that's what I remember. So I remembrance of it. So you're moving that pen along a graphics tablet. You have that curtain over, so you can't see your hand, right? All you can see is on the screen. I think it's the green or it's the white dot in the picture. You're starting at the green. You're starting at the green dot, and you have to move your hand so the cursor lands exactly on one of the red ones, right? And the other thing I remember about it is there's a movement time component, right? You have to move within a certain target.
So we set a criterion movement time so that we know for these sets of studies that we can be sure that people have time to use online adjustments. So the movement is within a feedback loop, if you will. So you have enough time to use visual or proprioceptive information to make adjustment to the movement, because the earlier work on this showed that online control starts at around these tasks around 250 to 300 milliseconds. So we set that movement time longer than that. So we're pretty confident that people can use online control or can use movement and proprioceptive and visual information to plan the next movement more accurately and use that, what we call offline control.
Right. And then you can look at basically because the movement time synced, right? You can look at I remember the landmarks of the movement, right? The peak velocity, the peak amplitude. And the way that I think about it is if the variability of those is going down and down and down, then there must be some online adjustment, right? If you're getting more consistent as the movement goes, then you must be doing some adjustment online. If not, then it's more planning adjustments, right?
And there's a very subtle nuance with that, in that you could argue that there's lots of motor control theories and movement control theories that basically would suggest that's how we move, right? You have some variability in the movement, and then of course, when you hit the endpoint, the variability reduces because that you're going to hit that target. So you would expect to see that increase in variability and then decrease. But what the important bit is here is the comparison between conditions. Or within conditions. So then you can compare, is this condition using more or less online control relative to another condition in this? So in this paper, it's internal and external focus. And that stems from the early work where we were stuck in this lab for 5 years doing this as a PhD, which we compared vision to no vision. So in those studies, we use this methodology to look at how do people use visual control when they do or don't have it. And then we adopted that methodology to look at, and how does internal, external focus of attention affect these online and offline control processes?
Yeah. So in the first experiment, they can see the white dot, the cursor, representing the pen position as they move, and they're asked to hit these targets. Vicki, what was the focus of attention manipulation?
So basically, internal focus of attention, focus on the motion of the hand. External focus of attention, focus on the motion of the pen.
Yeah. Just an aside question. I've done a similar one in baseball. Is it surprising to you that makes such a difference? You're basically they're right beside each other, right? They're, if the pen and the hand are the same place, like in any other kind of attention research we do in psychology, the classic stuff, they're so close together, like you wouldn't think it would matter. Were you kind of surprised by that?
Yeah, definitely. I think that's probably what sort of got me fascinated in this area of research as well. If you think you get a difference between such a simple, one word change, then imagine what's happening when you're giving, multiple or extensive in instructions or imagery script or whatever it might be. So initially, as I said, we just wanted to sort of play around with these aiming movements, because a lot of the previous literature had looked at sort of quite outcome measures of performance. We had some sort of kinematic work done by sort of Keith Lowe and colleagues, and some EMG, but we wanted to try and understand a bit more about that side of the literature.
And so in this first experiment, what did you find? I didn't the massive table of all the data of the movie. I didn't put that on the slide. But what did you find in terms of online versus planning for the first one? Just kind of in general.
Yeah. So broadly, I suppose we had an amplitude in the aiming task. It's got that amplitude component, and it's got that directional component. Broadly, we find, to be honest, I've got to remind myself, because we had
I had this one
error, but in short, we had when the participants using an internal focus of attention made less error, and then that was supported by reduced variability early in the movement trajectory, which is of enhanced planning mechanisms.
So the internal focus of attention had better movement endpoint that, based on the variability profiles, was due to increased planning, because there was not changes in between the conditions in how they controlled action during the movement. It was more in the early stages, which is too early, arguably, to use afferent information. So it's more reflective of better planning of an action.
Okay. So when you compare the two focus of attention instructions, the difference of variability is right at the start of the movement. Yeah.
And then we infer that as they're planning the action to be more consistent, or they're planning the action to reach the target without any adjustment. And they're doing that more or better in the internal compared to the external focus.
Yeah. So there's a transfer right after training. No, the transfer was a different distance, right? I think. Right.
Yes.
So was this what you expected from me? I was kind of surprised, because you as you say, it is a proprioceptive task, but to me it seems to be very visual with the cursor. Like you can do it with purely looking at the cursor movement.
It's Vic. It's Vicki. It's published now, so we can be honest. We did not expect this. We expected external to be better than internal. And then when we took this away, internal would be better than external, right? So when we found this, it was a bit, what's going on here? Maybe we need to do the no vision now to see if it's even better in the internal focus of attention or not. But I expected external might be better, because you've got this visual cue, you've got a target you're aiming for, you've got an action, clear goal to the action that would benefit from having some external focus on that goal. That's what I thought would happen, and then we didn't see that benefit.
Yeah, I think perhaps if we had if I just the focus instructions, so you got that motion of hand versus motion of pen. I think one of the things we discussed in the paper is that perhaps if that external focus instruction, so motion of the pen, had been to do with the target, and the reason we didn't mention the target in that was to try and make sure the instructions were consistent in terms of internal and external. But had we mentioned the target, then perhaps we might have found that benefit of an external focus. I'm not sure. We'll have to try it, because the initial reasoning to do this was really to better understand those underlying motor control mechanisms. And yes, we probably did expect the external to be better, but no, it was a nice surprise in a way. And as always, more questions.
James Roberts, he's now at Liverpool John Moores, got me involved in a study similar to this, single study, where we had a focus on the target, and that actually enhanced performance in that external focus.
Yeah.
So it may be that in this visual dominating task, if you focus on the actual goal itself, which in this case is that arguably the target, but you do need to control the movement of the cursor. Be like the flight of the ball, I guess, in a football or golf task. But we do see differences between that focusing on the pen versus focusing on the target. So there are subtle differences, even that simple in a task.
Yeah.
Simple base task, tiny change in that instruction. It's amazing.
That's what I agree with you. And I think this was the fairest, most direct comparison, the hand and the pen. Yeah. But I think you're right. Probably even if you had said focus on the movement of the cursor, which is external focus. Like, so not all external foci are the same, right? So, you have to kind of pick. And so that was pretty surprising. Yeah.
Yeah. And it's so, if you look at it, motion of hand versus motion of pen, it's so it, to come up with those instructions and agree on those instructions, even that took us a long, long time, because there are, there's loads of things to consider, isn't there? And and especially for a proprioceptive task, it's challenging, and there is a lot of issues with the instruction, with instructions throughout the literature. So it's just, trying to get
this
that
was
right.
going to be, I remember, this was going to be a quick study. Let's do this quick because it's all set up. The lab's all ready to go. And then 5 months later, we're still saying, what should the instructions be?
Yeah. I know the planning part surprises me a bit too. You think if you were cueing someone to focus on the feel happens when you move, right? So it's surprising to me that I know that's a simplification of it, but
But I think go on, Vic.
I was going to say, though, that was, to be honest, that was another surprise for us. In the focus of attention literature, there's a lot of discussion about movement planning, and there's some work that Keith Lowe's and colleagues have done on that. But there's, as far as I'm aware, there's not been anything previously that's really looked at that motor control and that online control, movement adjustments that need to be made during the movement or error corrections, whatever it might be. So I've lost my thought what we were.
Yeah, no, sorry,
it may be that they're both making some similar online corrections, but the differences between the two are only occurring in planning because they're both able to make online adjustments, but internal are focusing on the planning as well. And it might be that what they're doing is by focusing on the movement, they're able to then understand what went wrong during the movement to correct that on the next trial.
Yeah, I was wondering about that myself. Yeah,
I mean, that's what the offline planning is, but I guess they're basically using that sort of the feedback from the last trial for a better feed-forward model on the next one. Yeah. So they're still using the online control, or still using the online feedback, but just not till the next trial.
Yeah. No, I think that's a good point. I see that talked about somewhere, but sometimes the external focus should make you better able to process the feedback you get your action. So it should help you, planning in the sense, because it's going to be information for planning the next movement. But yeah, that's really so. So the second experiment you did the exact same thing, but essentially move the cursor, right?
Yeah.
So you see the pen cursor at the start of the trial, but is it as soon as you start moving, it disappears?
Yeah, once the cursor moves off that dot, exactly, it disappears. So you can't see the white cursor anymore on the screen. And as you said at the start, your hand is covered by that sheet, so you have no vision of the task, basically.
Yeah. So you'd either have to perfectly do a ballistic movement, right, or somehow use proprioceptive feedback to adjust your hand movement to hit the target.
Yeah.
And
it's interesting with that proprioceptive feedback in this task. You kind of forget because you do it so often, or I've done it so often. No one else, please, unless you come to our lab, don't do this. Your repetitive strain injury, but actually, you do get some additional feedback maybe to proprioception that you might not in a sports task. In that you get some feel from the tablet. There's some friction. So you do get additional things other than what we might just call proprioceptive feedback from muscle position in space. And you probably get some auditory feedback because you just know the pace you're going. You can hear that. You can just hear the slide on the tablet. That's too quick. That's the right pace. That feels like it's going in the right direction because the pen is giving me some feedback as well as the proprioception from the muscle, I guess.
And in this one, are the retention and transfer conditions blind as well, or?
Yeah. You don't. Yeah. So we didn't give them visual information in those two, as I recall.
Yeah. So there's no specificity of practice kind of issues, really. Yeah.
No. Yeah.
And so this one, the findings were a little trickier, right? So.
Yeah.
Can you? Yeah. Maybe.
Well, if I remember correctly, we had in terms of the amplitude versus directional components. I suppose the findings were a little clearer in terms of that amplitude component where we saw the benefits of an internal focus. But I will just remind myself.
Yeah, I think one of the instructions led to an undershoot, consistent undershooting the target. One led to consistent overshoot.
So the external consistently undershot and the internal consistently overshot the target. And we got the same in benefit and planning on that transfer task where they have that break on the internal over the external focus of attention condition that we did in experiment 1. And I think the absolute error here, correct me if I'm wrong, was it close to significance?
So so the sign was different, but when you take the absolute, it looks like they're pretty close.
Yeah.
But I guess taking a step back, the idea of this one is when you take the cursor away, you're making proprioceptive information even more important for the task. So you might expect if this pattern to get even bigger, right? The very simple prediction. This pattern you found in the first one, the internal focus should get even better relative to. But that obviously studies very rarely go to your simple predictions. But so you do. So there was the big difference was in the transfer condition, right?
So the error was a little clearer. We got that. So the external focus of attention, they significantly increased their absolute error between retention and transfer, and then internal focus of attention, you got the opposite.
What did we see in the what did we get in the directional error, Vic? Remind me on that.
I'll just remind myself now. It was a little less.
We got bigger differences in directional error than amplitude error, I recall.
The one I was wondering about this is, the transfer effect is changing distance. Is this so? If I consistently overshoot the target in one condition, and then you move the target farther away, if I keep doing the same thing, I'm going to suddenly be more accurate.
Yeah.
But if you're not, but that assumes you're not processing where the target is at all, right? You're just using the same.
Yeah. You're just using some sort of endpoint planning of this. That's the movement I'm going to move towards. I'm just going to move to that target distance, regardless of where the target is.
Yeah. And that doesn't seem, I guess that's possible. But then you would expect big direction effects and a whole bunch of other things, I would think. If people were just using the same movement, stereotype movement. So again, this is kind of suggesting that the internal is somehow aiding a task where there's proprioceptive information is more salient. That's kind of maybe not as in a clear way, as simple a way as the first one was suggesting, but kind of you're getting some pattern here.
Yeah.
And is there anything else from that one? I think I don't think there was any. It was similar planning effects and variability effects, I think.
Yes. Yeah. Exactly. Yeah.
And
I mean, you said it right at the start. Is interesting with that. The third experiment was so different to these aiming ones.
Yeah,
and I think that was largely because when we looked at these two studies together, the plan was. The hypothesis was, well, the no vision one's going to give us great, lovely, clear results because that's really proprioceptive and has to be because you haven't got any vision.
Mm-hmm.
And then it was maybe this task just isn't really that proprioceptive. Maybe it's pretty automatic. Maybe we're pretty good at these tasks without having. We're just good at reaching and pointing at stuff. We do it all the time. So is it really subtle? The instructions are really going to give us these subtle differences. So let's do a task that we know is pretty novel, and then we'll make it even more proprioceptive in nature by adding something that makes you think about proprioception even more. Hence, that there's this big shift from these aiming tasks to this lower leg task.
Yeah, you're right. Yeah. So this task it can still be done visually even when you take the cursor away, right? You see where the target is, you see where the cursor is. You could, and especially given that the emphasis is on planning, you're seeing, you have all the visual information when you plan. So you're right, maybe it's not so this one this reminded me of some of the tests they use for like doing proprioceptive acuity kind of tests. So
this was a task we robbed from Toussaint and colleagues who had previously manipulated proprioceptive information. They talk about proprioceptive neglect, and they use this ankle weight to prevent that proprioceptive neglect, if you like. So it was quite a nice. I thought it was quite a nice task. It's completely different to the aiming tasks we'd used previously.
Yeah, so people are trying to reproduce an angle, right, in their knee, right? So they're blindfolded, right, in this?
Yeah, they're blindfolded. So there's two phases. There's an encoding phase and a recall phase. So the encoding phase, participants extend their leg, the knee joint, until they hear a tone, and that's the position, if you like, that they need to recall. And then they return to the start position, and then they have to recall that same position.
Okay, so you might bend their knee 30 degrees, and then it goes back to relaxed, and then they got to try to move it.
And I think there's three different angles in the practice in the practice phases.
Yeah,
and then we had a transfer.
Transfer with three different angles, three different ones to those angles that were in the acquisition phase.
Okay, so they're trained to go to three different angles, and then they test it in the transfer. Yeah. Like I said, I remember this from measuring how sensitive people are to proprioceptive information, right? Yeah, like a common thing you find after like ACL surgery or something, people get way worse at doing this kind of test. They're proprioceptive. So okay, so and so in this one you can measure. There's a movement time component, right, as well?
Yes.
Yeah.
So you can do the same kind of. So it's kind. Is it kind of an analog of the pointing one in terms of the things you can measure in terms of planning and?
Yeah, you can. I guess the directional component's more difficult because yeah. If you've got a start and a stop point, then you can clearly measure kinematic landmarks. The directional bit can get more tricky in that it's a pretty lateral movement, right? The knee doesn't like to move sideways, so you can get messy with that. But yeah, you can tie markers, kinematic markers, if you want to these movements to look at this online-offline control, how changes in the consistency of the movement, consistency of that leg movement changes as you start to home in on the target or start to slow down to realize you've made a little error and you make little adjustments in order to hit that target.
Yeah. And so what were the focus? I can't instructions on.
So the focus instructions on this one were it was focus on the marker.
Movement of the marker, wasn't it? I think.
Focus on the markers, moving into the correct position. Focus on your leg and moving into the correct position.
Okay. So the markers are they the motion tracking markers, you mean? Yeah.
Yes.
So
exactly,
yeah. So it's kind of analogous to the, wolf balance kind of thing where you focus on your feet versus the markers right beside your feet.
Exactly.
Yeah. And so let's see, I think I put the graph up here of your. Oh, and so the other manipulation you had was what you were referring to at the start with Gab was whether that you put a weight on their foot. So the weight is designed to enhance and augment the proprioceptive information, or
exactly. Yeah. So just increase that sort of strength of that proprioceptive information. Yeah. So we had a slightly different design this time. We used the repeated measures design, but then we had the two groups: this no weight group and this weight group. And we expected that with this weight group, where proprioceptive information was increased in strength or power, if you like, from the ankle weight, that we might see further benefits of an internal focus of attention. They're better able to use that proprioceptive information, which is in essence primed.
Mm-hmm. And then, so yeah, on the left on these graphs, the left is the no weight group we're looking at, and for that one, you found, was there no difference between the two conditions? The focus looks like
exactly. Yeah, exactly. No difference between internal and external.
But so that's kind of analogous to almost the visual. Well, maybe not.
A bit. Yeah. I mean, in the. It's a proprioceptive based task, but it doesn't seem to be that's what's governing everything in the control of that movement.
Okay.
There may be a planning of ballistic movement. I'm not using any proprioception. I'm finding the target. I've got an endpoint now located, and I'm going to move. Whereas when you put the weight on, you're increasing the salience of that proprioception because now you've changed the movement a little bit. You've changed the system, right? You put something in the way of it that says, "Oh, I've got to deal with this weight, this added weight. Now I've got to think about proprioception more effectively in controlling this action because my leg is no longer the normal weight that it is. There's an ankle weight, so now I've got to deal with that change to the motor system."
Yeah, that's so. The way I was thinking too is depending on the weight is going to have differential effect depending on the position of your leg, right? So you're going to have to take into account of it as you move, right?
Yeah.
So it's not just making your muscles tense or something where you get more proprioceptive. It's also something, you're right, it's like a perturbation that you have to deal with. Yeah. Or constraint. So people are doing better in terms of hitting the right angle, right? The target angle.
Yeah, exactly. But I suppose the interesting thing, which again we didn't necessarily expect, was that actually you only saw that difference when participants had time to practice with an internal focus of attention, or when they did that later in the study. So I think there's a body of literature that suggests it takes a bit of time, it takes practice to develop that neuroplasticity and be able to process proprioceptive information better. So it seemed if they did the internal group later in the study, they seemed better able to process that proprioceptive information, and that's where we saw those differences.
Yeah, that reminded me. So yeah, you did this was within subjects, people did internal, external in different orders, and you found an order effect.
Yes, exactly. Yeah.
So people that did internal first were better, or was there a consistent? I can't remember the pattern.
Yeah, people would use the internal focus of attention second.
Okay.
So after external focus of attention, they were better. Their internal focus was better than an external focus.
Okay. So when they already did that first, yeah, that's interesting. I've seen that in a few other of these kind of focus of attention studies, the order effects. The one I think what I've seen before is when you do internal first, sometimes it hurts the traditional pattern, because I think people have argued it's hard to get away from it. Once you've been kind of primed to pay attention to your body, it's hard not to anymore. Yeah, but that's interesting. So the task, a proprioceptive task, especially when you make it more salient, you're getting this advantage of the internal focus.
Yeah.
Exactly, but only when they have time, I suppose, time on the task.
Mm-hmm. Oh, yeah. So after they've practiced, yeah, I guess that's kind of a general thing we see. That's kind of one of the applications, I think, to sports and things like that. I think, just observationally, there seems to be massive variations in people's ability to tune into proprioceptive information, right?
Yeah, sure.
I know I'm terrible, but you're showing, yeah. So I don't know if you'd want to. Could we draw like a learning conclusion here that if you have an internal focus, you learn to use proprioceptive better?
Yes. Yeah.
I think. Yeah, I mean, it would be good to get a second study with more trials to see if we actually could really measure that. But yeah, it looks like it's going in that direction for sure.
So coming back around, so is that sounds like kind of consistent with the Toner-Moran idea, the somesthetic awareness. Of tuning into, if you really want to change and modify technique, tuning into kind of the feel and I think that's what they were arguing.
And I mean, if you think a little bit out of the box, I guess, in terms of this body of literature, if you think of Baylock and Carr's work in early 2000, where they give the experts that unusual weighted putter,
Funny putter,
and they understand that, this is how my movement feels. So you're just giving something into the system that forces them to learn a little bit and to focus more on that want of a better term, no pun intended, on that movement action. That then they're able to do that, which otherwise they can't. They can't do that without that perturbation to the normal movement system. And the weight's kind of doing that, but you only get that when they're an expert, right? They only get that. Yeah, you only get that ability once you've become an expert at a task, and then you can tap into really what it feels like if you put a perturbation in the movement itself.
Do you think it's because we're not used to paying attention to that? This information, we're so visual, almost everything we do, or I don't know.
Yeah, I think it just becomes so automatic. I mean, there's some good arguments by Stephen Scott for visual aiming stuff that proprioception is very automatic. It's incredibly reflexive, and maybe you can make it slightly less reflexive if you focus on exactly what you're doing. But you've got to learn to do that, and you can encourage people or help people to do that by putting a perturbation into the system, like the weight in this example, or that funny putter in Baylock and Carr's example. I don't know. I'm thinking baseball. You give someone a different weighted bat, do they know how they swing more or stuff like that?
Yeah, we actually one of the things, this reminds me of a method sometimes we use called amplification of errors, right? So sometimes when someone has a weird action in their swing, so a lot of coaches will use that. You give them a PVC pipe to swing, and suddenly any kind of hitch in it will suddenly make, you'll feel it suddenly jerk, and kind of draws your attention to it. I think in the same way, same thing, the flexible shaft putter. If you ever tried those ones, if you have any hitch in your backswing, it'll make the putter go offline and you'll miss terribly. But I think that's a really interesting idea. I think drawing into this, it reminded me. So we're talking. You go a little bit about automaticity. Does this? So it sort of almost fits with the whole story of the external focus of Gabby's. So the constrained action hypothesis is the main explanation for her benefit of external focus is it stops you from messing up automaticity.
Yeah.
Right? It pulls you away so you can't get in there and mess up. But what you're showing here is that, maybe you need to sometimes break it apart.
Yeah, on tasks where you need to have good feel, or you need to have that proprioceptive corrective awareness, maybe you need to break it down a little bit. You need to understand that by stopping that automatic movement a bit if you want to understand what went wrong in that automatic movement.
Yeah.
Otherwise, I think it runs and you go, why am I making errors? I don't understand. It's working okay. The scheme is so or the my action plan is so automatic. I can't tell you what's going on with it. It's just I just run it. Whereas, and then if you focus on that, then it enables you to. It goes back to Toner's work and Moran's stuff. That sometimes you need to focus on that, and if you want to make that correction, you want to adjust subtle movement actions.
Yeah. Yeah, I think it's an important point. I was talking about this with the one I had yesterday, and when we talk about when you're focusing attention, right? Is this modifying a technique, or is this in competition on the final green? Those are very different situations. And is it planning versus online? Is it execution versus? So I think in general, there's a lot of more subtleties to this story. I think that we need to pull out. These kind of things. Mm-hmm.
Yeah, for sure. I think the temporal one. I listened to the podcast. I listened to it today, but really interesting. So it's hopefully you're not focused of attention out. But it's definitely some really interesting nuances in the literature that we really need to explore further. I think that something you discussed yesterday quite a lot is that temporal element, which in the literature I think really hasn't been investigated much. I think that will be interesting for future studies and the real function of those instructions.
No, and I like this. I've been telling people I'm getting really tired of internal versus external for new task X. Like, I've been doing that for 20 years, 25 years. Stop. Unless for some reason, like in your case, to predict a potential difference, right? If you just predict a new sport that she didn't test yet, don't bother. External is going to be better. It is. It's one of the most consistent findings in this literature. But if you have some kind of, like Toner Moran, when you're trying to break apart a technique to modify it, or in this case, proprioceptive, then let's get all over that and test it.
So, agree totally.
Yeah. So, you guys are kind of, I think, extending this work or thinking about other?
Yeah. So I think the biggest thing, probably for me now, is looking at this probably in a more ecologically valid task. So some of the work we've done to get together actually is we have talked about talent development earlier, but we've got a nice prospective longitudinal study running with weightlifting. We've now finished data collection on that at the moment, but where we use machine learning and pattern recognition to look at which factors differentiate between, you can call them super elite and elite, or elite and sub elite groups of athletes. And one of the things that's come out of that pattern in terms of the data is in weightlifting is an internal focus of attention. So it seems that the better athletes, the super elite lifters, tend to use internal focus instructions more so than external. And potentially that could be a red herring in weightlifting. If you listen to coaches and athletes, there is a lot of internal based in instructions, elbows, hips, whatever it is. But so the next step for me really is investigating that so we're doing a study at the moment in weightlifting with internal, external focus of attention. So that will be really interesting to see the findings from that, because it's arguably a very proprioceptive task.
Mm-hmm. And it may be that, as Vic said, that the findings we're getting from that prospective study is actually just because it's a product of the system. Coaches use it, so because they've done more hours of training and they do more training they say, "Oh, use more of it." And you go, "Right, yeah," because that you're just doing more of what you're told to do. So to have that experimental study, I think, well, this is a very proprioceptive task. Perhaps it should be beneficial. We should be able to get an internal focus of attention to be more beneficial for technique, and maybe if technique is the driver for, which it arguably is for lifting weights, they can lift heavier weights or more weights more efficiently. And then in terms of the temporal stuff, I mean, we've been playing around with this for ages. We always said can you combine imagery and focus of attention? So imagery happens before the action, and maybe focus of attention is happening during the action itself. Mm-hmm. So could you have an imagery script that promotes an external focus of attention when you're imaging?
Okay.
And then, or one that has an internal focus during imaging. And then it gets around, it sort of taps into a little bit of that. Can you do this stuff before the action itself? So can you focus on, I don't know, so you're focusing on a golf swing, and you're focusing on hitting the ball in the right direction, and you're doing all of that, imagining that's happening, and everything you're imagining is about the action from an external focus of attention point versus feeling the swing of the club, the swing of the arms, and then that's all happening before the task.
Yeah.
And we've played around with that a bit, and you don't see any differences.
Really?
Yeah.
Yeah, I'm surprised that hasn't been. If there was differences, I'm sure it would be published, because the image. If you combine the imagery and focus of attention literatures, that's a lot of studies. So I'm sure someone must have thought of putting them together. Yeah.
Well, we did it for you. Did it? You probably you were Vic's external, were you, Rob?
I was. Yeah.
Yeah, I think that was Vic's last study. I seem to remember one of them. Yeah. And we played around with it for a lot since, and we still can't see any differences. So I'm trying to work out from that, what is this temporal thing like? That's all happening before the movement, and then when you focus during the action, you get these effects. If you focus before you start moving, you don't. In terms of this imagery stuff, when we've combined the two, So I still want to play around with that to see what's happening.
Try and do something out with that. It would be interesting to see if you could. Well, I guess a lot of the focus of attention instructions do focus on the feedback. It would be interesting if you could tease apart the after part too. Like if I got you to focus on how, I don't know how you do internal versus external feedback. Focus on, I don't think that would be difficult, but I think these are the kind of the interesting ideas to go in this area, kind of tease them apart. So cool, guys. That was really great. Thanks for taking us through that. There's some really interesting findings. So you guys can hang on for a second. I'm going to sign off, stop this, and say thanks, everyone. Okay, that's it for today's episode. Thanks for the fun discussion, guys. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.